All right, let's get right into it. Today we're talking about something that's not just an update or a patch, it's a full-on revolution in cybersecurity. It's called Zero Trust, and it completely flips the script on decades of security thinking. You see, for the longest time, we thought about security in a pretty simple way. It was like building a fortress. You'd have these incredibly thick walls, that's your firewall, and a big, deep moat all around it. The whole idea was to keep the bad guys out, and you just sort of assumed that anyone who was already inside the walls was supposed to be there. They were trusted.
And that right there is the big question we're all facing now. Because in our world, with the cloud, with people working from anywhere, with all our different devices, there's no perimeter anymore. The castle walls have basically crumbled away. So what do you do? How do you possibly protect a kingdom that has no borders?
Well, this brings us to a pretty stark realization. That old security model, the whole castle and moat strategy, it's just broken. It's obsolete. It simply can't keep up with the way we work and live today.
And this slide just lays it out perfectly. On the left, you've got the old world. A nice, clean line between inside and outside. So simple. But then look at the right. That's today. Our data isn't locked away in a server room anymore. It's scattered across different clouds. Our colleagues aren't just in the next cubicle. They're at home and coffee shops all over the world. The whole concept of inside versus outside has pretty much lost all meaning.
So to fix this, we need more than just a new tool. We need a whole new way of thinking. If we can't trust where someone is connecting from, we have to completely change what it is we trust. And that takes us right to the heart of the Zero Trust philosophy.
This is the mantra. You're going to hear it a lot. It's short, it's powerful, and it is the absolute core of the Zero Trust model. What it means is we have to throw out that old assumption that if you're inside the network, you're one of the good guys. Instead, we have to start from a place of, well, total skepticism.
So what is Zero Trust officially? It's a security model that's built on a pretty radical idea. You don't trust anyone or anything by default. It just doesn't matter if a request is coming from your office network or from the other side of the planet. Every user, every laptop, every single app has to prove it is trustworthy, and it has to do it every single time it asks for access to anything. It's security that is always on, always checking.
Okay, so that's the big idea. But how do you actually do it? How do you put this philosophy into practice? Well, it really boils down to three core principles. This is the blueprint for building a Zero Trust architecture. And these three ideas really build on each other. First up, verify explicitly. This means you're always checking and authenticating based on all the data you have, who the user is, how healthy their device is, where they are, you name it. Second, use least privileged access. This is huge. It means people only get access to the absolute minimum they need to do their jobs, and not a single thing more. It really limits the blast radius if an account ever gets hacked. And third, and this one is a real mind-bender, assume breach. You literally build your system as if the bad guys are already inside. The game then becomes about stopping them from moving around and doing any real damage.
Now, to make that assume breach idea a reality, security folks use this really clever technique called micro-segmentation. Think of it like this. If Zero Trust is the philosophy, micro-segmentation is how you actually engineer it. It's like building a bunch of secure little rooms inside the castle instead of just relying on the outer wall.
And this is where that assume breach principle really comes to life. Micro-segmentation is basically like putting blast doors and security checkpoints all throughout your network. So if an attacker manages to get into one room, well, they're trapped. They can't just wander around looking for valuable stuff. It stops them from moving laterally. This approach contains threats, shrinks your attack surface, and as a bonus, it's a huge help when it comes to meeting tough compliance rules like GDPR or HIPAA.
Now, this all sounds amazing, right? But let's be real. Implementing Zero Trust isn't like flipping a switch. It's a journey, and it comes with some pretty significant real-world challenges. But before we dive into the tough stuff, let's be clear. The effort really pays off. Research shows that organizations that go through this process see a huge drop in security incidents, sometimes as much as 40%. So yeah, the payoff is absolutely there. But getting there can be a climb.
So here are the four biggest hurdles. First, scalability. When you're constantly verifying every single request, it can slow things down, and it takes a ton of computing power. Second, economics. This stuff costs money. There's a big upfront investment, and that can be really tough for smaller companies. Third is legacy integration. You know, trying to make Zero Trust work with old systems that were never designed for it, it can be a total nightmare. And finally, there's privacy. That always-on monitoring that's at the heart of Zero Trust can sometimes bump up against privacy rules like GDPR. So it's a really delicate balancing act.
So keeping all those challenges in mind, where does this go next? Well, the cutting edge of Zero Trust is being tested in these really complex mobile environments. And for a great example, let's take a look at a drone.
This is where things get really wild. You see, a device like a commercial drone doesn't just stick to one network. It's designed to be multi-rate. That means it can jump between different radio technologies. It can go from high-speed 5G to a long-range, low-power network like LoRaWAN to Wi-Fi, you name it. And every single time it switches networks, it crosses a trust boundary.
So let's follow this drone on a quick mission. It starts out on a super secure 5G network, its identity is verified, its trust score is sky high. But then it flies out of range and has to switch to a LoRaWAN network. Suddenly, that 5G identity means nothing. The new network has totally different security rules. Its trust score just plummets. Then maybe it hops onto a local mesh network that has almost no security at all. Trust drops again. So every time it jumps, it has to start from scratch, proving its identity all over again, which costs time and precious battery life.
And this all leads us to the final, really big question we need to answer. In this world that has no perimeters, the next great challenge isn't just about verifying who you are at one moment in time. It's about figuring out how to build a kind of trust that can actually travel with a device, a portable, cryptographic proof of identity that doesn't just disappear when you cross from one network to another. And whoever cracks that puzzle, well, they'll be leading the next security revolution.